Essay 4.6 Combined Probability. In today's video, we will be discussing the ways to present the probabilities using Venn diagram and the tree diagram, and we will also discuss the various probability rules. So first of all, let's discuss the Venn diagram. So Venn diagrams are a tool that can visualize which outcomes belong to which events, even with the multiple events. So if you look at this screen right now, I have like this empty or templates of the Venn diagram, right? So first of all, we can say that the bigger space, the rectangular box is our sample space U. This is our sample space U. And we can say that there are event A and event B. If we say that we only consider the event A in a Venn diagram, this is the case of the. In this case, we can simply say that this is the this Venn diagram is case of the set A, probability of A, numbers of the A. If we say there is an event again A and B with the sample space U, and if we say there's only or we only consider the event B in this sample space, then we can say this is case of this set B, probability of B, or numbers of the B. Or if we consider all the cases of the event A and event B, such in this way. So if this is the Venn diagram that is presented to you, then we can say this is case of the P, probability of A union B. Okay, so this symbol here is the shape of the U, and it's called the union. Okay, or we can say the number of A union B. Okay, we will talk about these cases that involves N a little bit later, but this is also represents N A union B. If we also consider a case where we have sample space U, event A, event B, and if we are only considering the case between A and B, then this is case of the probability of A intersect B. So the symbol between A and B here is called the intersect, or it looks like the U in backward. Or we can also represent this with the A union B, number A union B. Or there can be a case where we have sample space U, event B, event A. But in this case, if we just consider the case outside of the A union B, like this, then this case is considered as the A union B complement case. So A union B prime is considered as this outer space and is the complement case of event A. Okay. Or we can also use the complementary formula, means if we do 1 minus probability of A union B prime, then we can calculate the probability of A union B, right? Or we can also simply present this case as like if we say, okay, we have these two event cases, and then we can present this case as the event A, whole thing is event A. In that case, outside of this event A is considered as the complementary event of the event A. Then this Venn diagram represents the case where event A plus event complementary event of event A is equal to 1, right? Then let's talk about the next case. So in this case, we have a event B and event A within a sample space U. Okay, so you can see that these two events are disjoint, right? So these two events are disjoint, and in that case, set A and B are independent, but they also can be mutually exclusive case. Okay, so we will talk a little bit more about mutually exclusive case a little later. Okay, but this is how you represent the independent or mutually exclusive case. Then let's talk about the subset case. So in this case, we still have sample space U, and we have event A and event B. So you can see that event B is actually part of the event A, right? So in this case, we call this case as a subset case. Okay. Also, we can say that event B is subset of event A. And this is this is few examples of the Venn diagram. Okay. Okay, then let's discuss the tree diagram. So tree diagram is another way to represent the probabilities. So it is more open, efficient to illustrate the sample space using tree diagram. And when there are relatively few trials and few outcomes, especially for finding the probability of a specific chain of the outcomes. Okay, so the ways to illustrate this method is using branches for an event and the number of the branches as the number of the outcomes. So let's apply this method right into the example. So if you look at example number 1, we need to illustrate the possible outcomes when two coins are tossed using tree diagram. So two coins means we need to have a trial for the first coin and second trial for the second coin. Okay, and this have to happen simultaneously. Means since we know that whenever we toss coin, there's chance of getting head or the tail, right? So we're going to use H for head and the tail for T. Okay, so when you try to represent this probability case or event case, as I told you, we need to consider the two trials, right? One trial for first coin, another trial for the second coin. So we first going to let's try to have two sections for each coin. So we have trial 1, number 1, and trial number 2. And trial number 1 is for the first coin, and trial number 2 is for our second coin. Okay, so since we have two outcomes for each trial, we can start with the two branches first. Okay, so we always start with the dot and then go through the branches based on the number of the outcomes. So the first branch is the case where we have head, and the second branch is the case where we have a tail. And each case has 1/2 chance of having it, right? So we can say that 1/2 chance of getting head or trial. Then whenever we get the head, then we're going to toss another coin, and that's for the trial number 2. And when we toss another coin, there's going to be another outcome, right? So there can be a head and a tail, and each of them has 1/2 chance, right? And then same thing for the second time, or the case where we have a tail. we will have a head and tail as outcome for the second trials, and same thing, we will have 1/2 chance. And after that, you need to calculate the total probability of happening. So it means we first have to calculate the case where we have head and head. So in this case, we have 1/2 times 1/2, which is 1/4 chance, right? And then the next chance is having head for the first one and the tail for the second one. So again, we will have a 1/2 times 1/2 chance, which is 1/4 chance. And we will have a case where we have tail, and for the first case, and then for the second case, we can have the head case. In that case, we will have 1/2 and 1/2 chance again, so 1/4. And then lastly, there can be a case where we have a tail for the first coin and then tail for the second coin. And in that case, again, we will have 1/2 times 1/2, so 1/4 chances. So after you found the total probability for each cases, you can add all of them down the column to check whether they add up to 1. So in this case, we have 1/4 plus 1/4 plus 1/4, and this, so it adds up to 1. So this tree diagram works. Okay, that's how you illustrate the tree diagram. So now let's try to apply this into an actual example. Okay, then let's do example number 2. So we need to consider a case where two classmates, Jim and Lisa, are playing archery, and the probability that Jim hits the bull's eye is 1/4. That means the probability that Jim misses the bull's eye is 1 minus 1/4, so it's 3/4. Okay, then since the Lisa hits the bull's eye with the probability of 4/5, the probability that Lisa going to miss the bull's eye is 1 minus 4/5 or 1/5. So question A, we need to find the probability of them both hitting the target using a tree diagram. So what we need to do is we need to create a tree diagram before finding the probability of them both hitting. So let's say Jim is shooting first and Lisa is shooting next. Okay, then since they're happening simultaneously, we can say that Jim hits the target, misses the target with 1/4 chance and 3/4 chance. And then Lisa hits the target and misses the target with 4/5 chance and 1/5 chance. And same thing, if the Jim misses the target, there's chance that Lisa going to hit the target with a 4/5 chance and miss the target with 1/5 chance. Then we can calculate the total probability of where Jim hits the target, Lisa hits the target, using the tree diagram, right? So we have to calculate this part. So we can say that the probability of them both hitting the target is same as 1/4 times 4/5. So it's 4/20, which is 1/5. Then question B, we need to find the probability of at least one shot hitting. So we know that this is same as 4/20. Let's actually calculate all the probabilities first. Then where Jim hits the target and Lisa hits the target is same as 1/4 times 1/5. So it's 1/20. And the case where Jim misses target, Lisa hits the target, is same as 3/4 times 4/5, so it's 12/20. And the case where Jim misses the target and Lisa misses the target is same as 3 over 4 times 1 over 5, so it's 3 over 20. So actually all of this add up to 1, so we can say that this trigram works, right? So this is 20 over 20, so this tree diagram works. That means for the question B, we need to find the probability of at least one shot hittings, right? So means we need to find the probability of one hit, right? At least one hit, and the probability both hit. So what you can do is we can find the prob cases where at least one of them is hitting, which is this and this. So it is same as 1 over 20 plus 12 over 20. And we need to find the case both of them hitting, because it's at least one shot, right? So its final part will be 4 over 20. So we can say that the case where the probability at least one shot hitting is same as 17 over 20. Okay, and that's the answer. Okay, then let's talk about the final way of representing probability. So the final way, or the most common way of presenting probability, is using the sample space diagram or the table of the outcomes. So, or it's also called the two-way tables. Means we just present the probability or the information in the table that's shown with the example number 3. So we use information provided to decide whether to write the list or create a table to find all possible outcomes. And systematically, we need to write the list or fill in the table by either listing outcomes or performing operations with the values. And we need to use this information from the list or table to find any possible probabilities required. Okay, then let's do example number 3. So whenever you do a case where you have a two-way table and if the total outcome is not provided, you always have to start with finding total outcome for that case. Okay, so if you look at the example 3, let's look at it, and we can see there's a two-way table and total outcome is not provided. So let's try to identify the total number for each column and the row. So here we have total 72 child, right? And then so we have total 72 children, and we have total 58 adults, and in each case we have 83 here, and then 47 people dislike the ride, and we have total 170 people available in this case. So question A, we need to find the probability where this randomly selected person liked the ride. So 83 out of 130 people, we are referring to this part, actually like the ride. So we can say that probability that the person like the ride is equal to 83 over 130. Question B, if it's a child and dislike the ride, and means we need to find the case where the child and then dislike the right part overlaps, right? So we need to find the probability where the child and dislike the right. So this becomes 17 over total people 130. So this is approximately you can say 0.131 if you're using GDC. Question C, we need to find the probability that the random person is another or dislike the ride. So we have to find the probability that the person is a third or disliked the ride. So we need to look for the case where it is the person is a third, so 58, or this like the right? So we have to look at the case of 58 over 130 plus 17 over 130. So this is equal to 75 over 130, or you can simplify the fraction and leave it as a 15 over 26, or you can also use GDC to write it, the answer in decimal.